You have to be from the Panhandle to pronounce this next gentleman's name. Mr. Kevin Urbanzik is going to talk to us about groundwater monitoring in far west Texas. Kevin was instrumental in the starting of the new water center at Sul Ross State University. He serves as a director of Brewster County GCD and the data manager for Presidio County Underground Water Conservation District.
Thanks for getting the name Texas correct, at least. So yeah, I'm going to talk about groundwater monitoring in far west Texas, mostly Presidio and Brewster counties. And you see the list of affiliations there, Brewster County Groundwater District, the West Texas Water Center, I'll mention once or twice. Billy Terrence here, our new interim director, and me, we're the two people that are kind of affiliated with it now. It's a new center at Sul Ross. We're under Borderlands Research Institute, which you may be aware of. Formerly, my Rio Grande Research Center is going to kind of float off into the sunset at Sul Ross, and we're going to transition my activities into the West Texas Water Research Center. And then there's Presidio County. So let's see. What do I push? Maybe I'll figure this out. There we go. So I kind of mentioned this already, but a kind of brief outline. The water center is important to us, so I just want you to be aware of it. By the way, Water in the Desert, which we hosted almost 2 years ago, is coming up again this January, just FYI. You'll see some information coming out about that shortly, we hope. I do a lot of work with Presidio County Underground Water Conservation District. Trey Gerfers has really been he's the general manager there. He's sitting over here. He's really been able to generate a lot of funding for some monitoring equipment and activities that I'm going to talk about here. That includes funding from the USGS National Groundwater Monitoring Network and from the Horizon Foundation. So we're putting the sort of final stages into a pretty aggressive installation of equipment for monitoring out there that Trey got the funding for. Brewster County, our board is represented here also. Some things we're doing is we're developing some new rules based on some limited production issues. I'm not really going to talk about that in this presentation, but that's one of our activities. And then I will talk about today, provided I have the time, some concepts about us developing some management zones within a really big county and how we would like to look at groundwater levels and conditions in specific spatial locations. And then just in general monitoring efforts. So if we start with Presidio County, right now we've got 24 wells. This is over and above what the Water Development Board is doing out there. We've taken over a few of theirs. And what we're doing, we've got equipment out there that logs. So we have 24 of them, actually, and 11 of those 24 are right. So you understand, far west Texas is big and wide open. There's a lot of terrain in Presidio County that doesn't have cell coverage. So we have 11 of them are in areas where we do. And in those wells, we have OTT Ecolog 1000 instruments in there. Let's see if we can see that. That's this one over here. Those are actually intended to be deployed inside the well casing if you can have access to it. In that case, we've got it just kind of mounted on the outside. That's a data logger there, and it's got a little antenna, and it sends a signal to a cell tower, basically, and that's how we get the data out of that. So we have 11 of those, and then we've got 11 that are outside of a strong enough cell signal or any cell signal, and for those, we're using geostationary satellite technology. FTS is the vendor, Forest Technology Services, and those transmit to basically, as it says, a geostationary satellite. Whoops, let me see if I can back up there. There we go. right. So that's this one. This one's in Shenandoah Mountain State Natural Area. So basically, you've got a transducer, and both of these are attached to transducers that are down in the water that are detecting the water level changes. In this case, that one's deployed there. We've got a data logger inside this enclosure. That's the FTS, and it's remote, right? So we have solar panels, and that little strange-looking thing up there is the transmitter for the geostationary signal that goes. To me, it's incredible technology. That satellite's over somewhere over Hawaii or something. This thing, twice a day, it's sending a little 10-second packet of information that's very critically timed in the timing, because that's our little 10-second window. So I've gotten a lot of, Trey and I both have benefited from Andy Weinberg with the Water Development Board, and London, and Cody. Cody's out in West Texas to help us, because these are basically the same instruments that the Water Development Board had been using. I think they may have shifted to a different data logger than the FTS system, but still those are the ones that we're using, and we've benefited from their help in getting those put out there. Okay. Oh yeah, there was that one other thing. We got two of them that are kind of legacy within Presidio County that use an Iridium satellite system, just a little bit different, but those two are still there. So here's where they are. Here's a map of Presidio County. So we have the symbology there. The OTTs are the red ones. Those are in the locations where we've got a cell signal. And then the blue ones are the geostationary ones. So they're kind of more distributed in the more remote parts of the county. And then the symbology there on the map is we're primarily looking at the igneous aquifer. That's the reddish color. And then the West Texas Bolsone aquifer is down in the Presidio Redford version down to the lower left. And then the other Bolsone that's west of Marfa. I'd like to point out that two of those are literally 3 hours from where I start. You know, Alpine's over there in the county next door. It's not that far away, but the two that are hard to get to, well, they're all hard to get to, but there's one over here in Shenandoah Mountains that's in the far left, and then there's one down here. It's Haviline Camp in the Big Bend Ranch State Park. Those are 3 hours from where I start. So you really have to think about what you're doing. We end up spending camping out. You know, you have to take a couple days if you really want to go see everything. But so travel time is kind of important to us. That's one reason we want to have these logging, because we can't just go out there and collect the data periodically very easily. And by the way, I'd like to point out that we had 2 failures with our FTS systems. We deployed these within the last several months. And you can guess which 2 failed that we had to go back and collect. It's those 2 that are each 3 hours from Alpine. I mean, that's the way it worked. So those have arrived back in Alpine after their repair in Vancouver, Canada. So hopefully Trey and I and maybe some students can go on a little adventure to go out there and get those put back out there. Okay. So more details about what we do with Presidio County. We use the HAF groundwater management system. They're out here. And the original procedure before I came into the picture was that they had a staff member who would grab the data that comes through the cellular. It's an FTP site that you log in, and you have to kind of filter through the data and find out what needs to go into HAF. Or at that time, it was those Sutron Iridium systems. So somebody was charged with kind of doing that and trying to archive and then logging on to the HAF system and typing the numbers in and that kind of stuff. And I just don't think I just didn't like that. So basically what happened is, you know, that promotes the potential for data entry errors and in fact, fatigue. I think that some of the staff members just kind of quit doing it. And so that obviously wasn't what I wanted to do, and I don't think it's what Trey or anybody else wanted to do, but that was the system then, right? You remember that. And then, you know, ODD has an online dashboard where maybe the board could look at the levels and stuff, but that was not in the budget at the time. So what I did when I first came in is just develop some code in Python to facilitate the data download, archiving So basically, I've got two modules in the code that I wrote. One of them gets the FTP data, and there's a lot of other information than just water levels. You got battery voltages and some other kind of metadata about the data that you got to be careful you save. The half site just wants the levels and the day, basically, so I can process that and make that available. But still, that left us with the problem of, are we going to type these numbers in every day? And the answer was no. So what we did is we kind of custom built, or half did it for us. We contracted them to make a import CSV little button. So if you use half, you probably don't have that button because we paid for it. So basically what it allows me to do is just hit that button, point it to the file where I just processed the data, and it goes in there and it's done. And we don't have those problems with fatigue and data entry problems and that kind of stuff. So that's one of the things that made things work for us. And I'm sure some of you are probably data managers or maybe working with other districts, you may have something more elaborate, but this is working for us now. And now the other thing I've done there is made this all work. We've got 11 geostationary satellites. That was not very difficult to fit into that whole system. It was just a new thing. And I would like to point out that I did all this in Python before I realized you could use AI to help you with that kind of stuff. And if you saw that talk yesterday, one of the bullets that says this is really good at is coding. And since then, I still do a lot of our work in Python, and I have benefited from some AI technology to help with that. But at the time when I did this was all blood, sweat, and tears on my part to get that to work. And it works. So one of the things Presidio County wanted was to look at trends. So they asked me to look at trends in groundwater levels. If you just saw Allison and Grayson Collier group next door, they're at a level a little farther than we are in terms of looking at trends and maybe relating them to DFCs. But I want to show you how I interpreted what the board wanted to look at trends and what we did to do that. So we grabbed a bunch of well data, basically the stuff you can download from the Water Development Board, and we had some in-house stuff that's in the Presidio County archives. So you can see there's a lot of potential there for a lot of different kinds of data. There's 800, 900 wells. The different databases have different numbers. There's some issues we need to resolve with that. But then if you look at the ones that just had water levels, because that's the question, we're going to look at trends in water levels. The TWDB data had 626 individual wells with levels. Sometimes it's just one, but all I was doing is just looking at the data. And then the number of total records, any particular well is going to have more than one water level measurement. So that's what the total records are. So we have a lot of numbers to look at and potentially ways to interpret trends. So what I chose to do, or actually first, what the data looked like, so the total time span was from 29 to 75. Some wells, like I said, only have one or two measurements. Some of them have a lot. Some of them have a lot over a short period of time. So there's a lot of variability in what the data look like. So what I designed, just first stab, we're looking at the data, and then we're going to try to clean it like what Allison was talking about next door. So we wanted to find, okay, which wells have more than 10 records over more than 10 years? Maybe that's valuable. Long time span, at least 10 measurements. Then of what's left, maybe there's some with 2 or more. So let's look at some with fewer measurements, but still a long time span. And then lastly, those that are less than 10 years and less than 2 years. So we divided them up into different groups like that, so we could look at them maybe individually. And after doing that, now we've whittled things down. We have 37 wells that have a lot of data over a long period of time, 165 of them that might only have 2, but over a pretty long period of time, and then 5 in that other group. Some of those are our new ones where we have a lot of data over the last year. So we have 207 wells now that maybe have fallen under some type of criteria that we developed. So we want to look at this and see what kind of trends are there, and then statistically look at those trends. So in order to look at the trends, as this first stab, like I said, I just developed a linear regression technique. I did all this in Python, by the way. I'll show you a little bit of that code in a minute. Don't want to be a math professor up here. I'm a geologist, and a professor too, by the way. But the linear technique is just y equals mx plus b. The software will read your data, the little scikit I think I used in Python for this, and you just get a y equals mx plus b that's going to be a best fit straight line through the data that may or may not be straight. But you can look at some quality parameters. There's an R squared, kind of what it says there, the goodness of fit. If your R squared is closer to 1, that means all the points are kind of right along the line. And then there's a p-value that is of statistical significance. So we looked at both of those and developed some thresholds. Our thresholds, I'll show you here in a minute, are pretty liberal because, well, we're trying to fit a straight line to some curved data, for one thing. But, like I said, this is our first stab at doing this. Just what I said, time series groundwater data, they're often not really particularly linear. But I wanted to put those thresholds or use those statistical parameters to sort of categorize the data. And so I just created some categories. If your R squared is greater than 0.5 and your p-value is less than 0.05, let's call those good. And then if it's R squared is greater than 0.3 and the p-value is less than 0.1, that's kind of weak. And then unreliable. We threw all the unreliable ones out after that. So those are our thresholds. So there's a couple examples of some real data with lines drawn on them. Those are just the generated regression lines through the code. And what I did in this, some of the board might be here, I'm not sure, but these are the kind of stylographs that I give every 2 weeks when I process the data anyway, except it's got the regression line on there. Time on the x-axis, water level, feet below ground surface on the y-axis. And so the red line fits. The one on the left would be considered weak. You may not be able to see what I've done is I stick the R squared and the p-value up there. And I honestly, from my perspective, I can't see that from here either, so you probably can't. But basically the point there is when you look at any one of the individual graphs, those parameters are printed on it, but the software looks through it and sorts them out and ranks them as good or weak or unreliable. So those are a couple examples. We chose in this first stab to look at all data, including those with only 2 records. Maybe that's important, maybe that's good information. But the thing about 2 points in a regression, it's like a regression home run. With only 2 points, your R squared is 1, your p-value is 0. So I didn't feel like that was fair, so I always automatically downgraded any of the records that only had 2, or wells that only had 2, from good to weak, just because it didn't seem right to me to use it with just 2. So that's the description of the data processing. So then I was able to just decide some time spans. So you could do the full period of record, 1925 to 2025, or you could, all this is in Python, and so you could just change the dates, if you can see that window in the bottom right. And one of the things I'd like to point out about doing this in a script as opposed to processing this data, which you could do all this I'm describing in Excel, is that it's very reproducible. I could show you how I did it and do it again. I think that's pretty important. I have nothing against using Excel and doing this kind of data processing there, but sometimes if you forget how you went from one step to the next or did it in a different order, you might get different answers. So anyway, this is all coded and I can reproduce it. I can change the criteria, I can change those thresholds, change the time frame, etc. So those were the time spans that I chose to look at. The 20 to 25 being the sort of recent data, the 1980 to 2000 being, the decade before and then on. Okay, so to summarize what I've been doing, We select wells based on how many water level measurements and the time span duration. We select date ranges for analysis. We run that regression analysis. And by the way, every time you change the time span, the regression changes because it's only specific to that time span. It's not just subsetting it from the original full time span. And then we categorize them as good or weak and toss out the unreliable ones. And then filter by the aquifer, because there's that too. So which aquifer are you looking at? So we have igneous. The board has a column in there. This is the water level data column where they mix some other in with the igneous. So that's why it says igneous other. But then there's this other column that's other, which I think is probably Rio Grande alluvium mostly. But then and the West Texas Bolson. So we can look at all these per aquifer. And that's as fine of a resolution of focusing in on the data as I went with this. And so now that we've spent a lot of time talking about numbers, I thought I'd show you a picture of a pretty spring out there. This is near Valentine. So ooh and ah over that. That's a nice little spring. So let's look at a table or two. And I'm not going to overdo this, but I just kind of want to point out what we're getting out of this. The top set of rows is the full time span. That's 1929 to 2025. And then if you look at the bottom of the top set where I have the red circles, that would be right there. Over the full time span, and by the way, this is all aquifers. This is not igneous or West Texas Bolson. It turns out that of the ones that passed my criteria, and I did lump the good and the weak together because just more data. There are 63 have a trend in feet per year that went down, and 63 that had a trend in feet per year that went up. So it was like exactly the same almost. In fact, almost the same number in feet per year. But then if you go down and focus on just at the bottom, this is the 2000 to 2025. Now we have, I think it's 18 that went down. And by the way, that number where we're saying it goes down it's a weighted average. That's a little hard to explain. It's not, but you got 18 wells there, so it's the average of those basically. And the ones that went up there were only 6 of them, and they went up at a smaller amount. So maybe we're seeing some different, maybe production, maybe climate-related issues. We're not interpreting yet at the moment. We're evaluating. What are the trends? That's what we're doing. So those are the trends we see over time. And then if we look at the West Texas Bolson aquifer, 4? By the time you narrow it down, you kind of lose records. So we only have 7 that pass the criteria. 4 of them have a trend that's down in a negative, the value's -1 1 foot per year. And 3 of them went up a little bit. And then if we look at the igneous and other, a lot more went down in the 2000 to 2025. 14 have a trend down, and only 2 of them have a trend up. Again, we're looking at the data, looking for trends. Then we're going to have I don't know, what do? You have another look, you try to clean it. They're talking about incorporating precipitation, climate patterns with it. There's a lot more we can do with this. But this is our first stab on the trend analysis. So if we do want to take this data and maybe say something about a DFC, this is very simple. We can just project those weighted average trends out for 50 years. And that's just kind of doing some science here, trying to apply it to a DFC that's associated with 50 years, and it does say that it's average water levels. So basically, the trends are produced in a way that's a weighted average, which is weighted more heavily to the direction where there's more wells that are represented there. For example, for the igneous, 88% have a negative trend because they were 14 out of the 16 wells during that time frame that contributed to the overall decline of 15.87. I'll admit, too, that I did not put any error bars on here, but I did calculate those. I just didn't have time to stick them on here. So that 15 is going to be plus or minus maybe up to 5 or something like that. So it's just a ballpark thing. But it is approaching, and it's very similar to what the DFC is, coincidentally, for the igneous aquifer, which is 14. So I'm not saying we're hitting that. We're not trying to, but this is our first stab at a way to look at trends and what the water levels in Presidio County are doing over time. And the West Texas Bolson trend is, you can see that's the second from the bottom, has a 50-year condition of 20.87 feet down in a negative direction, but the DFC for that one's 72. So Trey and I have talked about this a little bit. Maybe that's an excessive DFC. So this whole conversation about DFCs and MAGs, like we said in what I think Allison talked about, that's in the modeling world, and then DFCs and levels are in the physical world where we go out and measure it. And I know Brewster County, we spent a lot of time talking about this, kind of scratching our head and asking Bradley with the Water Development Board how we do this, and we don't know. We're learning. Brewster County, we're probably going to be trying to do this same kind of thing because we want to have a better feel. But we're like, how do we track a DFC? It seems to be given to us, but physically on the ground, that's what we're trying to figure out. And maybe this is a start for Presidio and Brewster counties for understanding that. There's just a table with all the wells that fell in the category. Nobody wants to look at that, but here's where they are. The ones that we use for the igneous aquifer are in red in that map on the right, and it's a cluster of wells around Marfa up here, including Section House, Marfa 5, and maybe 1 or 2 of the Marfa production wells that they're using, which makes you suspicious, okay, those are directly related to pumping, even though a couple of those aren't pumped, but they're near wells that are pumped. Maybe a couple of these down here are too because they're on some ranches. But I know this one is nowhere near any well that's being pumped, yet it fell in the category of a decline, statistically valid maybe. So maybe there's some things that are happening out there that are not just directly related to pumping. That's another question we'd really like to look at. And just an example of a graph over there. And this one down here that's Moreno, nowhere near any pumping either. What this graph the map doesn't show are the bolsons, because they have similar, there's a decline there too. And a lot of those are down near Presidio where there are production wells in the bolson there. So there's data for us to look at in terms of sort of moving forward with this. Okay, so that's the Presidio County component, and how am I doing for time? I'm about there, or I'm there. Well, let me just say, Brewster County, we're looking at management zones. I won't take any time on it. We're using some geochemistry and some watershed boundaries and stuff, but we don't have time for it, so I'd rather just not exceed my time. So how's that? Thank you.